In the previous video, we started to talk about how to enhance our graph using labels, titles, texts, legends, color fields, transparency, um, and patches, right? Color patches, that kind of thing, right? And let's keep talking about how we can actually enhance our figure by using those capabilities provided by Matlab. This time we're going to talk about mathematical symbols. Right, including those Greek letters, that kind of thing. Right, so how do we actually use mathematical symbols when we actually make a plot? Right. So again, let's try to create some kind of fake data. Again, OM1 is just a link space vector. It goes from 1 to 2 with 100 points. Right, and then let's define a variable that's called beta. Beta equals to 3. Right. When we are writing computer programs, we cannot actually write Greek letters. Right. So we can actually, what we have been doing is to replace those Greek letters with the English word beta, right? But when we actually make a plot, say figure 10, we can actually embed those mathematical symbols and Greek letters into the figure, right? So let's make a plot first. Horizontal axis is going to be OM1, that's the frequency, and then the vertical axis is going to be cosine 4 times pi times OM1, and then dot multiply exp minus 1 plus OM1 dot get beta, and then we're going to use black, right? So that's basically just going to be our figure, right? Let's execute this section of the code. Right, that's going to be our plot, right? It's this kind of an oscillating curve, this kind of thing, right? Let's dock this figure. Right? So the first thing we're going to do is to actually add a title to it, but the title is going to contain mathematical symbols. So we're going to look at the so let's write the title function. But what the title is going to display a string, right? It's going to display a string. Maybe let's change the font size to like 14 or something, right? But what's going to be the string that we're going to try to display, right? We're going to try to display something that's going to include italic or tilted, those kind of slanted letter, right? Italic letter, and then we're going to include subscripts, right? Subscripts, and then we're going to include Greek letters. So how do we actually incorporate all those kind of special kind of formatting, special kind of letters into a normal MATLAB text string that can only accept those words or those characters that's on our keyboard, right? So suppose we want to specify a italic or a slanted character G. So we want to display the character G in italic, right? So the font is kind of tilted, right? So how do we actually do that? We can prefix it with \it, right? So backslash is some kind of a very special character, which means that MATLAB is gonna, every time MATLAB sees the backslash, it's gonna try to interpret the stuff that's behind it as some kind of formatting string, right? So if you have used HTML or if you have used some kind of a markup language, right? In those markup languages, you have special kind of characters, special kind of symbols to represent the format instead of the content, right? You have to separate the content from the format. Here, the content is the letter G. We want to display the G, but \it is going to tell MATLAB that how I want to display G. I want to display it in the italic mode, right? So this backslash is the MATLAB way for defining a format string. So the format is going to be \it, and then the content is going to be the character G, right? So suppose let's just execute this line. Let's see what's going to happen, right? So now we are seeing a tilted G here, right? A tilted G, italic G, right? So now let's keep writing our expression, right? And then we want to give the G a subscript. and this subscript is going to be a number. It's just going to be a number 2. So how do we actually give it a subscript? We use a underscore, right? So suppose we just do underscore 2, then let's just run it, right? Then you're going to see G with a number 2. That's more or less as a subscript, right? But if you actually pay attention to the display, if you are careful about the display, you're going to see that the number 2 is also tilted. It's also in italic mode. The reason is because this formatting string is going to be applied to everything behind it, right? So if you don't want the number 2 to be displayed in italic mode, we have to sort of prefix it with RM, Roman. And then if we do that, this subscript, so dash backslash RM is going to cancel out this sort of effect of the ID, or it's going to impose the Roman format, font to the subscript, right? But if we do that, this subscript is gonna subscript what? It's gonna subscript not 2 anymore. It's gonna subscript dash backslash RM. Do you see the dilemma, right? So how do we actually make sure that it's the whole thing that's being subscript instead of just a portion of it, right? We use curly brackets, right? So here it's not a cell array, right? It's just a formatting string, right? And then now let's try to evaluate the selection. So now you can sort of see the 2 now is not tilted anymore, right? So if you want to sort of group together a bunch of stuff, you have to use the curly brackets in this kind of formatting string, right? And then let's try to add some normal text. RM, say versus. So the word versus is gonna have a formatting string again, RM, right? So let's try to run it again. Right, versus. That's the normal word versus, right? G2 versus omega 1. So omega, we want to display the omega as a Greek letter, right? And we want it to be a capital Greek letter, right? Capital Greek letter, capital omega. So how do we actually incorporate a Greek letter, right? Again, backslash, right? If we just type omega, backslash omega, then it's going to try to display the small case Greek letter omega, right? Let's again run it, right? Sort of see the small case omega, right? But that's not exactly what we wanted. We want a capital omega. So how do we actually do a capital omega? We just capitalize the first character behind the backslash, right? And this way, it's going to give us a capital omega, right? And again, we want omega to have a subscript, right? Subscript 1. So this time, it's going to give us a subscript. Right, that's omega 1. Right. Omega 1. And then 4. Let's again use the italic mode, right? So we want to tilt it. And then this time we want a small case Greek letter beta, a tilted small beta. And then Roman word equal. So this equal is going to be sort of formatted in the normal Roman font face, right? And then equal to 3, space 3, right? So now let's rerun this piece of code and see what's going to be the effect, right? So G2 versus omega 1 for beta, a tilted beta, right? A tilted G equals to 3, right? So that's sort of the effect that we want, right? So that's for the title, and then let's do the label. Say Y label. So again, we have to specify a string that's gonna include some kind of special mass symbol, and then font size Again, let's set it to like 14, right? So what's going to be the stuff that's inside of the string? Italic G underscore backslash rm2, right? That's going to be our Y label, not label, BEL, right? And then what's going to be our X label, right? X label, capital omega underscore 1, right? So that's going to be our labels, right? So that's G2 and then omega 1, right? For some reason I forgot to actually increase the font size for X label, 14. Right, so that's gonna give us a X and Y label that includes math symbols and Greek characters, right? And now let's try to do something that's slightly more complicated. We're gonna try to create a text string inside of the graph, right? And then the text string is gonna locate, the start of the text string is gonna be located at 1.2 x coordinate, 1.2 y coordinate, 0.08. Right? And then what's gonna be the content of the text string, right? Again, italic G underscore rm2 dash rm equals to cosine backslash omega 1 backslash rt. And then this time we're going to do an exponential. So exponential is going to, the exponent is going to appear as superscript, not as subscript. It's going to appear as superscript. So how do we actually specify superscript? We use this kind of pointed hat. It's exactly the symbol that we use to raise the power of something, right? So that's for defining a superscript, right? And then the superscript is going to be a quite long string. Then so we're going to encapsulate everything. We're going to capture everything inside of this kind of curly brackets. The stuff that's inside of the curly brackets are going to be the exponent, right? That's going to be the exponent, right? So we're going to use rm dash 1 plus backslash omega on capital omega underscore 1, and then raised by power again, right? Backslash italic, and then backslash beta rm, and then we're gonna use a parenthesis. Right, and that's gonna be the string that we're going to try to display, right? And then font size, we're gonna use like 24. It's kind of big, right? Font name, we have seen font size before, but we haven't seen font name. Font name, we're gonna use time, and then color, we're gonna use blue, and then font weight. Font weight is going to be bold, right? And then let's execute this line and see if we made any mistakes. Right, it's going to look like that. It's going to look like that. Right, that's exactly what we are, what we expected, right? So G2 equals to cosine omega 1 times e to the minus 1 plus omega 1 to the beta's power for beta equals to 3. Right, that's like a quite a complicated mathematical symbol that actually uses superscripts, subscripts, Greek letters, and it's actually quite complicated, right? So that's an example of how to use mathematical symbols and how to incorporate Greek letters into our formatting strings. The most important thing to remember is this backslash, and then all the rest of the formatting stuff can be actually found on the internet, right? You can just Google, and here is a collection that I found on the internet. So for math symbols, right, this backslash. So if you want to use the not equal to symbol, do backslash neq, not equal. If you want to use the larger than or equal to symbol, you do backslash geq, right? Approximate symbol, this kind of thing, all those things. All those mathematical symbols, partial derivatives, right? Partial backslash partial, and that's gonna give you this particular mathematical symbol, right? So if you want to do an integral backslash int, it's gonna give you this integral symbol, right? So that's all the mathematical symbols. And then if you want to use the Greek letters in your text string, here's another table for Greek letters, right? Greek symbols. So if you want to use alpha backslash beta, right? All those things. Right? If you want to capitalize, just capitalize the first character behind the backslash. Then you're gonna get the corresponding capitalized Greek letter, right? Greek symbol. So all those text representations of those special mathematical symbols and Greek letters can be found as this kind of table on the internet, on the web, right? And that's mathematical symbols. That's mathematical symbols, right? In the previous video, we started to talk about graphic handles, right? But we haven't talked about the handles in detail, right? And the handles is actually a very convenient way for us to manipulate figures. So let's spend some more time to talk about graphic handles, right? And let's try to create another figure, let's say figure 11, right? Again, let's use the two crossing curves as our example. So x goes from x equals to length space 0 to 6 with like 100 points, and then y. Let's not create a y at all. Let's plot x cosine x with black, and then x 1 dot divider coshx with a black dash line, and then the vertical line, right? 4.73. 4.73. That's x, right? And then y is going to be -1 to 1. -1. Right, that's going to be our that's going to be the two curves, right? And then let's put some labels on it. X label, X font size 14, and then Y label, functions, then font size 14, and then title, realization of two intersecting curves, and then text 4.8 minus 0.1, x equals to 4.73, and then font size 14. Right. So let's just execute this piece of code, and let's create the figure first. Right, that's the figure that we were trying to create. Right. So last time we created this figure. We're putting a legend box right here, right? We're putting a legend box right here. But what I can tell you is that this legend function also returns some kind of output, right? Which is a handle to that particular legend box, basically, right? So let's call the legend function. Legend function cosine x 1 over so shx, right? That's the two legends that we are using, and then the location. The location was southwest, right? That was the legend function that we were using last time, right? But the legend function also returns a handle. let's give like two things, right? Why we've got like two things, right? Why do we have two things? Why do we have two outputs, right? Later on, you're gonna discover what those two outputs actually represent, what those two handles actually represent, right? So suppose we use the set function on A, and then we're gonna change the property called line width. So let's run this line first, right? And then we're gonna be able to see this this particular legend box right here, right? And then set, let's do set A. We're gonna change the line width to 2, and then the color to yellow, right? Let's run this particular set line and see what's gonna be the effect, right? So you can sort of see the effect now, right? So the line width has increased to 2, so which gives us this kind of outline, the legend box outline, right? The legend box outline is thicker and it has a width of 2, right? And then the color, we change the color to yellow, right? So you sort of see what's the background color changed to yellow, right? So this handle A is actually a handle that allows us to change this legend box, the box itself, right? And then let's look at the handle B. Let's look at the size of B first. We've got like 6.1, right? Why does it have like 6.1, right? But let's make adjustments to B1 and B2, the first two elements. So set B1, say font size to 14, and then color to blue, right? Let's change B1. So you can sort of see B1 actually controls the text right here. See, cosine x, the font size has increased, and the text color has changed to blue, right? And then let's try to set B2, right? Again, font size to 14, and then color to red, for example, right? It doesn't have to be red. It can be anything, right? So the font size has increased, but for this case, the font size has increased to a size that's kind of too big, right? And then it actually goes outside of the legend box now, right? So if I do legend box off, so it's gonna give me a better effect, right? But the background color has disappeared, right? So you can sort of see the effect of changing the different properties of a particular handle that's returned by the legend function, right? And then let's do some more experiments. Right? But still by using function figure handles. Let's create another one, figure 12, right? But this time we're gonna here we're basically just plotting all the functions together, right, in like a one plot command. But here we're gonna just do something. We're gonna ask the plot function to return a function handle hc equals to plot x cosine x, and then k, right? And then hold on, right? That's hc, and then hch, the cosine. Let's plot x1 divided by cos hx, right? And then k dash dash, right? So that's gonna be a function. So hch is gonna be a function handle that's returned by plotting this 1 dot divide cos hf x function, right? And then let's still get one more function handle. That's plot 4.73 minus 1 1. Okay. Right. So we've got like three function handles returned by the three graphic handles returned by the three plot function calls, right? And then we're not done yet, right? We have legend boxes, but let's create the figure first. Let's create the figure first, right? So that's our figure 12. That's our figure 12, right? We're not done yet. We still have the legend box, right? A and B equals to LE, GE and D legend cosine x 1 divided by COS HX, and then location is southwest, right? And then X label. So this time we're going to use some special mathematical. So backslash IT means italic, right? Backslash BF means boldface X, right? Backslash IT backslash BF. So it means I want to display X in italic and boldface, right? That's going to be, and then font size, that's going to be our X label, 14, and then font name is going to be times. Right, that's going to be our X label. Y label is still going to be value of functions, and then font size is going to be 14. And then let's add a title. Title this time let's use boldface BF, and then visualization of two intersecting curves, right? And then font name is going to be Korea. It's a special kind of font. And then font size is going to be 14. Right. And then the last thing we're going to do is to do a text 4.8 minus 0.1, and then italic x space equal to 4.73, right? And then font name is going to be times, and then font size is going to be, say, 14, right? So now let's execute this particular section, right? So that's the Korea font basically. So that's a text string that we have for being for x equal to 4.73. That's the sort of the times font, right? So don't forget that we have like three function handles here, right? We have three function handles, three graphic handles here that we has created, right? So now we have done pretty much all our plotting. All the data are displayed, right? So now let's try to make adjustments to those curves. So HC is a handle to this particular curve, right? Cosine x curve, right? So let's set HC line width. Let's change it to 4. Let's see what's going to happen. Right? It becomes thicker. A line width of 4. Right? And then HCH so now we set the line width of the COSH 1 over COSH function to 2.5, right? So now let's evaluate this particular selection. Now now you can sort of see the black dash line becomes thicker, right? And then set HSAO again line width 0.25. And then let's change the color to green, right? So we are making it thinner, making the vertical, not HSL, HCO, sorry, it's not HSL, HCO. Right, now let's run this line. Right, so this is a thinner green vertical line now. Right, so that's how we can actually change the properties of individual curves later on after we have finished plotting those curves, right? And then we can actually change its properties by using the set function, right? And then there is a very special kind of a graphic handle that's called GCA, right? Set GCA. GCA means the current active axis, right? The current active axis is what? The current active axis is actually this particular axis, the axis that we're actually seeing here, right? And it's also an object, and it's got properties on it. Let's change the font size. Let's change the font size to 14, and then the line width to 1.5, right? Evaluate selection, right? So now the you can sort of see the axis becomes thicker, right? And the font size now becomes bigger, right? So just one simple command allows us to actually adjust the font size of the current active axis, right? And also the line width of the current axis, right? It's called GCA. GCA is a global variable. It's a global variable, right? It's just like pi. It's just like now, right? It's a global variable, and this handle always points to the current active axis, right? It's a handle to the current active axis, right? So if you are plotting inside of figure 12, right, the current active axis is going to be the axis of figure 12, right? So maybe let's just make one more small change. Set B1 font size to 10, for example, right? That's right. Yeah, I think that's that doesn't have any effect, but I just want to. So we can use those function handle, those graphic handles to do various things, right? To do various things. One utility of this kind of a handle is to create a figure inside of another figure, right? Figure inside of another figure. Figure inside of another figure, right? So how do we actually create a figure inside of another figure? Let's figure 13. Let's create a figure 13, right? So we're just gonna sort of do a plot. Do this plot, right? Let's copy over. So that's this particular plot. Let's do an X label. Y label. And then title. And then text 4.8 minus 0.1, and then x equals to 4.73, right? So, and then legend cosine of x 1 divided by cos hx, right? And then location is gonna be southwest, and then legend box off, right? So figure 13 is somehow similar, right? It's just repeating all the stuff that we have done already, right? But this time let's try to actually put another figure as a sub figure inside of this particular figure. So how do we actually do that? How do we actually do that? Right. What we are going to do is that we're going to create, in order to actually make another subplot inside of this particular smaller plot inside of this larger plot, what we have to do is to actually create an axis inside of this plot. Right. And in this case, we have to use the Matlab axis function. So this axis function allows us to create a new set of axes on a specific location, on a specific coordinate, right? So if we haven't actually looked at this axis function before, right? But we can type help axes to actually find out how to actually use this particular function, right? So basically, it's going to take, the most important thing is probably the position property, right? So position is actually one of those properties of axis function, right? So and then you can specify the location and the width. Let's give it like 0.5, 0.6, 0.22, 0.22, right? So that's the x and y axis, x and y coordinate of the origin of this new axis. It's going to be at 0.5 location 0.5, location 0.5, 0.6, positive 0.6. It's kind of a, and then the width and the width in each of the dimension is going to be 0.22, right? So that's going to be our axis, right? And then OM, let's just use let me see what might be a good function for us to try. Do I still have that OM1 function? Yeah, I still have that OM1 function, right? I can just plot this one. Let me copy this code over. Right. So now after I call this axis function, creating a new axis, this plot function is going to create the curve inside of this new axis. Let's just evaluate this one. Oh, sorry, I got it wrong, I think. No, sorry. Let me recreate a figure 13. So that's going to be the location of the subplot, right? For some reason, it's kind of different from what I was telling you, right? So the coordinates is not exactly the coordinates that we are seeing here, right? So the coordinates are actually 0.5, 0.6. It's sort of in the middle, right? It's sort of in the middle of the it's 0.5, 0.6. It's right here, I think. It's right here, right? It's right here in the 0.5, 0.6, right? Yeah. So the coordinates that's being used here is not exactly the mathematical coordinates that we're actually plotting. It's actually relative to the current active axis, right? So basically, it's treating the horizontal and the current active axis as a unit of 1, right? So the whole width of the horizontal axis, the whole width is just a 1, and then the whole width is of the vertical axis is just 1. So the numbers here is sort of like the proportion, the fraction that you want to sort of position the origin of the new axis with respect to the current active axis, right? And then followed by width in each of the dimension, and then you make the plot inside of this new axis, right? And then for this particular subplot, for this sort of figure inside of another figure, if we also want to sort of put some titles, labels on it. We can also do that. Let me try to find the correct labels, right? Say title, X label, Y label, that kind of thing, right? Let's copy it over. And then let's just evaluate this selection. Right, so now it's got its own set of labels, that kind of thing, right? So this way you can actually put a full featured figure with all the decoration and all the enhancements inside of another figure with its own decoration and its own enhancements, right? So that's called a figure inside another figure. That's a figure inside another figure, right? So okay, that's sort of the last example I want to show you about two-dimensional graphics, right? And you can sort of see Matlab actually really allows you to do really complicated graphs, right? And this script is probably too long. It's over it's over 300 lines. So it's probably not a good idea to keep doing the two-dimensional graphics in this particular video anymore. So in the next video, let's try three-dimensional graphics, right? But this is just a very short, very brief explanation about Matlab as two-dimensional graphic capability, right? If you have any kind of comments or suggestions, or if you have discovered new ways of using two-dimensional graphics, or if you have found some very useful functions, right, for making two-dimensional graphics, please feel free to actually put them in the comments. All right, thank you.